right, so let's try number 23 out of 14.1. So we have here graphs for x, which is given by f of t, and y, which is given by g of t. And personally, I really wish we could just do without the f and the g. Okay, so let's. I'm going to just think about this as x of t, right? And this is y of t. Oops.
Y of y.
Y of t. How about y of t? Y of y would be weird. Okay. What now? Yeah, don't think about y of y very hard. That'll hurt. Okay, so what I'm supposed to do is describe the motion of this particle in the plane, right? Okay, so I'm going to go over here, and I'm going to say, okay, here's a plane, right? There's an x and a y, right? Okay, and I think probably the best thing to do is chunk this into time intervals that make sense, in the same way that you would do polar, right? You guys kind of recognize that? Okay, so I've got these two curves, right? What's your time interval on which consistent things are happening?
By one.
So over here it looks like by ones, right? And the x's, time units of 1 would be fine. This is kind of a t-axis and an x-axis, right?
Yeah.
Over here on the y's, what are the time units that make sense?
Half.
Halves, probably. Okay, so let me start with t is 0. Where am I at t is 0?
You're at 2, 0.
Yeah, that x is 2 and the y is 0. Okay, so I'm out here at 2, 0, and that's really thinking t is 0, right? Okay, now the next interesting one I think is that t is 1/2. Where's that?
1.5, comma
1 1/2, comma 1.
Yeah.
Okay, so 1, 2, 1 1/2 is in here, and we're up 1 unit, so we're like right here. And that dot happens at t is 1/2. How do we get there?
We read off of x and we read off of y.
Okay, but how does the thing move from t is 0 to t is 1/2? Like, how does the particle get there? Does it take some kind of roundabout rando path, or? Yeah, I mean, really, I should just connect the dots, but with what? Probably a straight line. I think probably a straight line makes sense, because what I'm talking about is going on right here, yeah? So the x is proceeding smoothly, right, in a linear fashion, so it's moving at kind of consistent speed, right? And the y is also moving at consistent speed. So I think that really probably is a straight line. So that's this guy. Boom. Just like that. Cool? All right. Where are we at t is 1?
You're at x equals 1 and y equals 0.
You guys all see that? Right? T is 1 gives me x is 1. T is 1 gives me y is 0. So that's here. And how did we get there?
Straight line.
Probably also a straight line path.
Are those lines the sum of the vectors, or are they just
Those lines the sum of the vectors.
like
Yeah, in some sense. So you could really think about this kind of thing, right, that's happening here. You could think about this as like f of t, right? That's made out of the vector x of t, comma 0, plus the vector y of, plus the vector what?
Y of t.
Yeah, it really should be y of t, but y goes in the y slot, right? So that vector should be a 0, comma y of t. You guys see that? Or really, you could do this vector addition, right? And think this is the vector x of t, comma y of t. Cool? Maybe? So, yeah, really they're the vectors that end there, right? Okay, so where's your next one? Where's your next interesting time?
1.5.
1.5? Okay, and at 1.5, the what?
You're at
X
x
and
is
a
a
half.
half, comma, y is negative.
Okay.
Is it -1?
-1, I think. Yeah,
Yeah.
so I'm down here again.
A half -1.
And that probably continued straight through, right? That's at t is 3/2. Okay, how about t is 2? Where's t is 2?
X is
0.
0, y is 0.
0, 0. Okay,
At origin.
so shabam like that. Okay. Oh, I should label that. That's t is 2 there. Okay, next.
And then a half. 1.
So
2.5.
next is a half in the x and
1.
1 in the y. Okay,
Yeah,
so
t
that's
is
something
2
like up
and a
here. And that's t is 5/2. Then when t is 3, what do you get?
X is 1, y
0.
is
X is 1 and y is 0. Okay. Wait, 1?
Yeah.
Oh. Oh, what did I fark up?
0. I don't know.
You guys see what I farked up?
Mm-mm.
What was the t is 5/2 dot?
Is there a reason
What,
we
2
keep
and a
going
half?
negative and now back to positive?
Yeah, what the heck? Why did I go negative? This dot, right, is at x is -1/2, but x is supposed to be +1/2.
Yeah,
So this dot should really be on the other
I was
side.
thinking a little earlier, this should look like a bow tie kind of.
Yeah.
Wow.
So then my t is 3 makes sense, right? T is 3 is x is 1 and y is 0. So that's back here.
Got it. Mm-hmm.
You guys believe the bow tie?
Mm-hmm. Let's go down a bit.
Yeah, so if we look at the next time period, right, this one happened at t is 1 and also again at t is 3. Right?
Mm-hmm.
So that was my bow tie intersection there. And then at 3.5, the y is -1 and the x is still more positive. So, yep, down to here. And then back up.
To 4.
Yeah, back up. So that's at t is 7/2. And then this one's at t is 0 and also t is 4. And I need maybe those little arrows on there. Cool.
Nice.
So let me just check in time, right? So if I just look at the x's, as time progresses, x goes from
Big to small.
4 to 2,
To 0.
4 to 2 to 0, and then from 0 back to
2.
2, and then back to 4. Oh, yeah, that's totally what it does. And then I can check the same thing for y. Cool? Does that help a little bit? Just a piece at a time. Just like a polar, right? When you're doing a polar graph, you just kind of chunk out, okay, there's this little arc, right, between theta's whatever and theta's whatever, and then you talk about the arc of the radius thing. So here you chunk little time intervals, and then do the x piece and the y piece for each. Cool? How would I make it bend? If I wanted a bow tie that was bendy,
Throw some eyes in
yeah, you could do that. So you could run to complex land to make it bendy. Alternatively, you could bend these little bits, right?
there? Okay. Yeah, I was gonna ask you about that. What if that meant like sine graph?
Yeah, so if these things were more bent, then I'd have to be more careful. And instead of drawing straight lines, I'd have to think about, okay, wow, the y is changing faster at the beginning and then slower at the end, and what does that do on my picture?
So we have to find like a slope and then add
Yeah, we might want to think at least about the rate at which things are changing. You guys see that? The rates in here are all constant, right? The slopes are all just pegged at some number. And so over here, things get straight, right? But if the slopes over here weren't constant, then this thing would be a little bendy.
What if the x was straight and then the y was bendy? How would you
Yeah, then you,
do half of it? Straight, not bendy?
well, half of it's straight and half of it bendy is still bendy, right? So yeah. If one of them is bendy, they'll probably be bent. Cool. Questions, Steele?